today we are doing conditional probability and talking about tables, which we've already kind of done the past 2 days. Conditional probability is the probability an event occurs given that a certain condition is met. The notation for this is probability of A given B. And then you have this formula. I didn't put this on the formula quiz because you don't really have to memorize another one. Remember that the probability of A and B, write this down please. The probability of A and B, what does and mean you're doing? Multiplying. You're multiplying probability of A times probability of B given A. So this is what you'll see on your formula sheet. If you look, probability of A and B equals the probability of A times probability of B given A. If I tried to get this by itself, if I tried to get that by itself, what's the opposite of multiply? Divide. So what would I divide both sides by? Probability of A. You would divide both sides by that. Do you see how that's what this formula is? Okay. It doesn't matter what letter. Well, actually, I will show you this right now, and we'll need it for later today. What letter is after the given right here? B. That's the one that has to go on the bottom. Or if you look at the way we wrote it over here, what was the letter that was given? A, that's the one that would go on the bottom. So whatever's in that second spot is going to go on the bottom. Yep. Okay, so we're actually not going to use this formula until later down on the paper. Okay, so we'll come back to this formula in a minute. Right now, we're just going to practice reading a table. Suppose that one of the seniors is randomly selected. What is the probability that the selected student has blue eyes? Okay, it says, who are they selecting? What kind of person? It says one of these seniors is randomly selected. So you need to double check. Are there certain people in the table who are seniors, or is everybody in the table seniors? Everybody. Why is everybody seniors? Right? It doesn't say they're not seniors. That's good. They also tell you at the top that these are seniors, okay? Remember, when it says what is the probability, you have to make a fraction. What always goes on the bottom? The total. How many total seniors are there? 200. That came from right there. 200 go on the bottom. And I'm trying to select a person with what? With blue eyes. Okay, how many people have blue eyes? 80. Okay. Remember on the test, you would need to reduce that. I'm not going to spend time on every single question doing that. Okay, you would do 80 divided by 200, math, enter to get it. Somebody tell me what it is. Okay, so that's the answer that would be on the test. Okay? All right. B, suppose one of these seniors is randomly selected. What's the probability the selected student is male and has blue eyes? Okay? Once again, who are we picking from? What's our total group we're picking from? Seniors. How many seniors are there? 200. Okay? We're selecting from 200 people. It says a senior is randomly selected, so there's 200 of them. Okay? Now it wants to know, I need ones who are male and have blue eyes. How many are male and have blue eyes? Male and have blue eyes, that is 40. That's the number that goes on top. Okay? Questions? Okay. C, suppose that one of these seniors is randomly selected. So as soon as I read that first sentence, I know 200 goes on the bottom because I'm selecting a senior. So there's 200 of them, okay? What is the probability that selected student has blue eyes given that they are male? Okay? Sorry, I just totally told y'all wrong on this. Sorry. Okay, so we are selecting a senior. So rewind, ignore what I just said, okay? What is the probability that selected student has blue eyes given that they are male? So what do we already know about the student? We know given that they are male. We know they're male. So how many total males are there? 110. That's what's going on the bottom because we know that they are male. We know that they are male. So there's 110 to choose from. Then out of that group of males, we need to pick somebody who has blue eyes, okay? So how many have blue eyes? Okay. All right, real quick, let me show you a way you could do this using the formula. So blue eyes, given that they are male, okay? Blue eyes, given they're male, that's the notation for that. If you go back up here and look at the formula, it means blue eyes and male divided by, which one goes on the bottom, blue eyes or male? Yeah, it's the one in the second slot that goes on the bottom. So if you use your formula, that's how you can get those numbers as well. So blue eyes and male, how many in our table had blue eyes and were male? 40. And then how many total males were there? 110. So the formula can also give you the answer. Okay, but you don't have to use the formula. You can use it, do it kind of common sense as well. Okay. All right, suppose that one of these seniors is randomly selected. What's the probability that the selected student is male given that the student has blue eyes? Do y'all want to use the formula or just kind of go about it common sense? Okay, so we know that the student has what? Blue eyes. Those are the people we're picking from, so that's what goes on the bottom. So how many have blue eyes? Yeah, it'll go in and say, how many have blue eyes? 80. Okay, total for blue eyes is 80. Now, out of that group, I want to pick a student who is a male. So how many are male out of that group? 40. Okay, that's an easy one. Without your calculator, what is it? 1/2. Okay. So for this one, given that the student has blue eyes, so we know they have blue eyes. We don't know that they're male on this one. Nope. It says, what's the probability that the selected student is male? Given that they have blue eyes. So we know they have blue eyes. So that's what goes on the bottom. Okay? All right. E, suppose one of these seniors is randomly selected. What's the probability the selected student has green eyes given that the student is female? Okay, so which one's going on the bottom? Green eyes or female? Female. Whatever's given is going on the bottom. Okay, so total females. How many total females are there? 90. Okay. Then out of that group, out of the females, then we're going to pick somebody with green eyes. How many people are there for that? 10. 10. All right, 10. And again, without your calculator, that reduces to 1/9. Okay, the zeros cancel. Okay. All right, does anybody want me to do one of those with the formula? Okay. All right. Number 2, the manager of a produce stand wants to find out whether there's a connection between people who buy fresh vegetables and people who buy eggs. To the nearest percent, what is the probability that a shopper bought vegetables? Okay. What is the probability that a shopper bought vegetables? What's going to go on the bottom? 200, the total. Okay. Because it didn't use the word given, it didn't tell me anything about that. It just wants to know the probability a shopper bought vegetables. So 200, your total goes on the bottom. Then how many people go on top? 105. Those are the people who did what? They bought vegetables. Okay, 105. It says to the nearest percent. So let's practice that real quick. Type that in your calculator. 105 divided by 200. All right, 105 divided by 200. And how many times do you move the decimal? Twice. Move it twice so it becomes 52.5%. Okay. All right, B, to the nearest percent, what's the probability that a shopper bought eggs and vegetables? Okay, again, what's going on the bottom? 200, okay? This time, though, we're picking people who did what? Bought eggs and vegetables. How many people bought eggs and vegetables? 56 bought eggs and vegetables. So 56. All right, what do you get when you put that in your calculator?
28%.
So what is it as a percent? What do I write? 28%. Okay. All right, now consider the probability that a shopper who bought eggs also bought vegetables. Write this question using conditional probability notation. So it means with this line thing, okay, with the line. Okay, I know that this is the part y'all hate because it's just all about reading, okay? A shopper who bought eggs also bought vegetables. What do we know has already happened? They bought eggs. That's already happened. That goes here in the second spot. This is the thing that's already happened, whatever's in the second spot, okay? After they bought their eggs, what do we want them to buy next? Vegetables. That goes there. Okay? All right. What is the probability that a shopper who bought eggs also bought vegetables? So that's the same question, but now we're actually going to put numbers in. Let's do the formula for this one. Let's practice the formula for this one. So this straight up and down line, it's V and E over, which one goes on the bottom, the V or the E? The E, good. Whatever's in the second spot goes on the bottom, okay? All right, so we're gonna practice that using the formula. So if you look up in your table, how many bought vegetables and eggs? 56. And how many bought eggs?
76.
How many bought eggs? 76, good. Okay, and so that would be your answer, very good. Questions? All right, flip it over. D, now consider the probability that a shopper who bought vegetables also bought eggs. Write this question using conditional probability notation. So again, you're doing the straight line, okay? Shopper who bought vegetables also bought eggs. All right, what do we know they have already done? That goes in the second spot. What they've already done goes in the second spot. What do we want them to do next? Buy eggs. Okay, so that goes in the first spot. All right, and now we're gonna use the formula again. What's the formula for this? What goes on top? Good, E and V. And what goes on the bottom? V, okay? Whatever's in the second spot goes in the bottom. Okay, so it's backwards of what you would think. It's backwards. Whatever they did, whatever they've already done goes in the second spot, whatever they've already done. So it's backwards of what makes sense, okay? All right, flip it back over. How many bought eggs and vegetables? 56. How many people bought vegetables?
105.
How many people bought vegetables? 105, yeah. 105. All right, number 3. All the upper division students, juniors, and seniors at a high school were classified according to grade level and responded to the question, how do you usually get to school? If an upper division student at the school is selected at random, what is the probability that the student usually takes a bus to school? Okay? Did it tell me that we already know what kind of student this is? No, okay? So the total goes on the bottom. How many total are there? 546, okay? And then what do we want that student to do? Take the bus. So what number goes on top? 180, okay? Okay. All right, if an upper division student in the school is randomly selected, what's the probability the student is a junior and usually takes the bus to school? So again, your total goes on the bottom because they didn't tell me that we already know what this student is, okay? But this time we're picking people who are what? Juniors and take the bus. Who's juniors and take the bus? 122. Okay. Let me point out something real quick. So this one had an and in it. And normally means we do what? Multiply. But not when there's a table. Okay? When there's a table, you just pick the numbers out. Okay? All right. C, if a junior student at the school is selected at random, what is the probability that the student rides the bus to school? Okay? This time, who are you selecting? you're selecting a junior student. So you already know they're a junior. So what number is going to go on the bottom? 274, yep. Okay. Then out of juniors, we want the ones who do what? Ride the bus. How many ride the bus? 122. Okay, they have to ride the bus and be a junior. Okay. Okay. All right, what is the probability that a randomly selected student rides a bus to school or the student is a junior? Okay. Now, for the or you still do the add and subtract even if it's a table. You still do the add, subtract rule even if it's a table, okay? What comes first?
180.
Well, hold on, like just in words, what's going to come first?
People who ride the bus.
People who ride the bus. Okay, people who ride the bus is going to go in front. So how many ride the bus? 180 out of 546. Then the next thing that comes is juniors. How many juniors are there?
122.
Yep, this time it's just juniors. Okay, so juniors are 274. And then you subtract the ones who ride the bus and are juniors. Okay, you subtract the ones that are both. So who rides the bus to school and's a junior? 122. Okay. Yep.
How'd you know what order to put it in?
Okay,
I'll
so
put the 122.
So when it's an or, you do this, you do bus to school plus student is a junior, okay? Bus to school plus student is a junior, and then you subtract bus and junior, the ones who overlap. Do you want me to say that again? Okay. All right, anybody?
Oh, what's the answer?
Yeah,
166 over 273.
273.
like that?
Yeah.
All right, 3 more. We can do this. At Sarah's Steakhouse, 35% of all customers order the baby back ribs. 12% of customers order baby back ribs with a house salad. What percentage of customers who order the baby back ribs are expected to also order a house salad? Okay? So, again, the question is asking what percentage of customers who order baby back ribs are also expected to order a house salad? What do we know has already happened?
35%.
That's true. But based on this question, what do we know about these customers that they're asking about? What have they already done? They already ordered the. What do they order first? Yep, they ordered the baby back ribs first. That goes in the second spot. What they've already done goes in the second spot. Okay. Then what do we want them to do next? Order a house salad. Okay. All right. The formula for that, when you have that straight line, that conditional probability, what goes on top? H and B. And then what goes on the bottom? B. Okay. H and B, and then B goes on the bottom. Okay, so look back up the problem. How many order a house salad and baby back ribs? 12%. Okay. 0.12. And then how many order baby back ribs? 0.35. Okay. All right, what do you get for this one? Okay, yeah. What is it as a percent? Anybody know it as a percent?
No,
Because
it's just 34%. 34%.
it said what percentage. So yeah, it said what percentage. So we'll do it as a percent. Okay. Questions? All right. Little Laurel's lemonade stand sells lemonade and cookies. Laurel writes down all the orders of her customers. She finds that of her customers today, 33 bought both lemonade and cookies, 15 bought only lemonade, and 9 bought only cookies. What is the best approximation for the probability of cookies given lemonade? Okay. Well, okay. I have to do an extra little weird thing on this one. So cookies given lemonade. What's the formula for that?
C and
Cookies and lemonade. Okay, cookies and lemonade over lemonade. Okay, so it looks like this problem would be really easy. The problem is you have to find the percents before you put them in. Okay, so to find out who bought cookies and lemonade, who bought cookies and lemonade? 33 people, but out of how many? Well, here's why this one's weird. So think about this. All right, cookies and lemonade. All right, so we know, oh yeah, it will work to just add them all up because 33 bought both, right? 33 bought both. And then this one says bought only lemonade, right? If they would have said, yeah. Oh, yeah, okay, so this is 15 bought only lemonade and then 9 bought only cookies. Yeah, so you can just add those. Okay. So this is 33 over 57. Okay. Oh, now I remember why this one is tricky. How many people bought lemonade? How many bought lemonade? Yeah, that was the trick. I knew there was a trick somewhere in this problem. Couldn't remember where. Okay, that's the trick, is that you have to add these two right here. Okay, so when you put this in your calculator, parentheses divided by parentheses. Oh, right there, that plus should have been in the divide. All right, 11 over 16.
Yep.
All right, 11 over 16. Okay, number 6, Josh owns a guitar shop. 43% of his customers order a Fender guitar. 14% of his customers order a Fender guitar with custom pickups. Find the probability that someone who orders a Fender guitar will also order custom pickups. Okay, so let's look at what the question is asking. Find the probability that someone who orders a Fender guitar will also order custom pickups.
That's and.
So you multiply.
Well, it's not an and. We already know something has happened. What do we know they've already done? They ordered a Fender guitar. We already know that's happened. And then what do we want them to do? Order pickups. Okay? All right.